students, let us work out the remaining problem that we have left before. Okay, so today's problems will be a little bit complex with the earlier questions. The first problem is, this is the first problem of exercise 7D. Y is equals to cos x, y is equals to 1 minus 2x by pi. So if we find the point of intersection, we can assume, we can imagine, we can observe that at x is equals to 0, at x equals to 0, both are intersecting, both are giving the same points. For example, x equals to 0 if you take and substitute, cos 0 is 1, so y equals to 1 we got that. And same x equals to 0 if you try substituting in this, then 1 minus 2 into 0 by pi, so this is 0, so both yields 1. That means both are intersecting at x equals to 0. And x equals to pi by 2, cos pi by 2 is 0, so y equals to 0 here. Pi by 2 if you substitute here, 1 minus 2 into pi by 2 by pi. So this is 2 gets cancelled, pi by pi is 1, so 1 minus 1 0. So cos pi by 2 is 0, and at pi by 2 this is also 0. And one more thing, pi, cos pi is cos 90 plus 90 minus sin 90 minus 1. So y equals to minus 1 we get. Same pi if you substitute here, 1 minus 2 pi by pi, pi cancel, 1 minus 2 is minus 1. Therefore, let us take x equals to 0. So next 0, pi by 2 and pi. And let us try to draw the diagram for these two. So this is minus pi by 2, this is 0, pi by 2, pi, 3 pi by 2, and this is 2 pi. So I have taken minus pi by 2 interval, and let us try to plot the diagram of y is equals to cos x. Cos 90 is, cos minus pi by 2, cos 90 is 0, cos 0 is 1, cos 0 is 1, cos 90 is again 0, cos pi is cos 90 plus 90 minus sin 90 minus 1. So this will be this. Next, cos 370, 3 into pi by 2 is 90, 390 is 270, cos 270 is cos 180 plus 90, so minus sin 90, because this lies in the third quadrant where cos is negative, minus sin 90, so this is minus cos 3 pi by 2 is cos 180 plus 90, so minus cos 90, minus cos 90 is, cos 90 is 0. So this is how the cos x is seem to be. Now if I try to draw the diagram, so this will be this. Okay, and now y is equals to 1 minus 2x by pi. So this will be this, because this is y is equals to mx plus c type of line, which is a straight line. So 0 if you substitute, 2 into 0 0, so y is equals to 1. So if x equals to 0, then y is equals to 1 minus 2 into 0 by pi, so this is 0. So x equals to 0, y equals to 1 is this point. And now if x is equals to pi by 2, then see what will happen. Y is equals to 1 minus 2 into pi by 2 by pi. 2 cancel, pi cancel, 1 minus 1 is 0. That means pi by 2 0 is this point. And x equals to pi, if x equals to pi, then y is equals to 1 minus 2 into x is pi by pi. So pi cancel. 1 minus 2 is equals to minus 1. So this is pi minus 1. Pi minus 1 is this. Therefore, this is the area we get. Now here if you see, area is this small region, right? This we can write it as 2 integral 0 to pi by 2, because this as well as this curve we want. Therefore 2 integral 0 to pi by 2, the upper curve here is cos x minus the lower curve is 1 minus 2x by pi dx. So if you find this, then this is the total area bounded by the two curves given. So 2 integral cos x dx is sin x minus integral 1 dx is x minus into minus plus 2 by pi constant, separate it from the process of integration. Integral x dx is x square by 2. Since the process of integration is over, 0 to pi by 2 is to be written here. So 2 into, substitute upper limit, sin in the place of x pi by 2 minus x is pi by 2. So 2 gets cancelled here, plus 1 by pi into, in the place of x substitute upper limit, pi square by 4. So this is all upper limit, minus lower limit is sin 0 0, x is 0, so 0 square by pi is 0, so this is all 0. This is equals to sin 90 value is 1 minus pi by 2 plus this pi gets cancelled, pi by 4. This is equals to 2, 1 minus, so minus 90 plus 45 is minus 90, so minus 90 plus 45 is minus 45. So this is equals to 2 minus 2 into pi by 4 is pi by 2. Y is equals to e power x, y is equals to x, x equals to 0, y, x equals to 1. So y is equals to e power x, this behavior of this curve A, you set it apart, put it apart. Y equals to x, this is y is equals to mx, this is a straight line that we know which is passing through the origin. X equals to 0 is y axis, x equals to 1 is the line parallel to y axis, otherwise a vertical line. So but we don't know the behavior of y equals to e power x, that's why x equals to 0, x equals to 1, let us take and substitute in that. So 0, 1. So y is equals to x curve, y is equals to e power x curve. So y is equals to x. If x equals to 0, y is equals to also 0. If x equals to 1, y equals to also 1. Now this e power x now. If x equals to 0, e power 0 is 1. Next, 1 you substitute, y equals to e. We know that e value is lying in between 2 and 3. So e value is lying in between 2 and 3. That we know the value. So with the help of this, let us try to plot the diagram. This is 0, this is 1, and here this is 1. So this is 2, this is 3. Somewhere e will be here between 2 and 3. Okay, e value which is lying in between 2 and 3. Now this is 0 0, y equals to x is 0 0. Next 1 1. So this is a straight line if you even extend it also. So what is this? Y is equals to x is the line which is passing through the origin and it is a straight line. And now let's come to this 0 1. 0 1 is this, and 1 e. 1 e is somewhere here. 1 e. Now this is, so this is this kind of a curve we are getting, and actually we can even extend it also, but not required. Here x equals to 0 is y axis, that is this. X equals to 1 is this line. So x equals to 1 is this line. See, now it is bounded or not, let us see this. X equals to 1 is the line which is a vertical line parallel to x axis, parallel to y axis. So that is this line, and x equals to 1 is this, x equals to 0 is y axis is this, and e power x, this is the curve, and y is equals to x is this line. So this area we are required to evaluate. So area A is equals to between 0 and 1 dx, dx is y dx. So 0 to 1, here there are two curves. One is e power x curve, that is a dominating curve, that is the upper curve, and below this is y is equals to x is the line. So e power x minus x dx. Integral e power x dx is e power x minus integral x dx is x square by 2. Since the process of integration is over, 0 to 1 limits are to be written here. So e power x is 1 minus e power x is 0 minus 1 by 2 you separate from the process of substitution. Now x square is 1 square minus same x square is 0 square. So this is equals to e power 1 is e minus e power 0 is 1 minus this is 1 into 1 by 2 is 1 by 2. So this is equals to e minus 1 by 2 is 3 by 2. So e minus 3 by 2 is the area bounded by y is equals to e power x, y is equals to x, y axis, and x equals to 1 occupy. X is equals to 4 minus y square, x equals to 0. So this is the parabola, but whose vertex is not at the origin, therefore it is not a standard form of the parabola. X equals to 0, we know that it is a y axis. So the parabola and y axis, but the limiting points, limits from where to where is not given, for which let us try to solve both of them. So solving, we get 4 minus y square is equals to 0, implies y square equals to 4, therefore y is equals to plus or minus 2. Now see, this is given curve is a parabola. Given curve is a parabola, that is x is equals to 4 minus y square. So this can be rearranged as y square equals to 4 minus x. This can further be rearranged as y minus 0 whole square equals to minus of x minus of 4. So this is a parabola whose vertex is at the point 4 comma 0, at the point 4 comma 0, and is symmetric about see here, y power even symmetric about x axis. Which x axis? Negative x axis, about negative x axis. Let us try to plot the diagram now. So this is the coordinate axis, and 4 comma 0 is 1, 2, 3, 4. This is 4 comma 0. So vertex having located at 4 comma 0, that is opened in the negative x axis, and in this process it obviously cuts the x axis, y axis. So which points plus or minus 2. Therefore, this is 1, this is 2, this is 2 comma 0, and this is minus 1, this is minus 2, this is minus 2 comma 0. Therefore, this is the ultimate parabola. Okay, so x equals to 0 is the y-axis. So this is the y-axis. This is the y-axis, and this is the parabola. So this is the parabola. So this area is what we are required to find out. So here area is equals to now with respect to y-axis now. So 0 to 2 are the limits of y. Therefore dy is x dy. So here this is actually minus 2 to 2. Minus 2 to 2, the total region. Otherwise 0 to 2 let us do. Since it is symmetric about x-axis, so answer we will multiply with the 2. Both are okay. Minus 2 to 2 dy is x dy, x is 4 minus y square. So what I mean to say is minus 2 to 2 4 minus y square dy. So that means we are directly try to evaluating the whole area. Otherwise this is similar to 0 to 2 x dy. So answer if you multiply with the 2, 0 to 2 means this only. If we multiply this with the 2, then this whole area we will be getting. Both are equal. So 0 to 2 x is 4 minus y square dy into 2 means actually this area also we will be getting into 2. So both are equal. So I am just rubbing this. Now let us try to do this. This is equals to 2. Integral 4 dy is 4y minus integral y square dy is y cube by 3 from 0 to 2. So 2 into 4, in the place of y upper limit 2 minus in the place of y lower limit 0 minus 1 by 3, in the place of y upper limit 2 its cube is there minus y in the place of y lower limit 0 cube. This is equals to 2, 4 2s are 8 minus 2 cube is 8 by 3. This is equals to 2 into 3 8s are 24. 24 minus 8 is 16. 16 by 3. This is equals to 2 16s. 32 by 3 square unit. X is equals to 2 minus 5y minus 3y square, x equals to 0. This is the parabola. Y square equals to x. So this is a parabola, but y square equals to plus x or minus x, which we don't know. Therefore a small simplification is needed. X equals to 0, we know it is y-axis. Same like the last problem. The last problem vertex we found. So the finding vertex was a little bit easy, 4 comma 0 we get. But here it is a little bit complicated. So for which first let us try to solve it. Okay, let us try to simplify it. Now this is 3y square plus 5y minus 2 is equals to minus x. So 3 into this is y square plus 5 by 3y minus 2 by 3 is equals to minus x. So why I am doing this is actually let us to know the behavior of the curve, whether it is y square equals to minus 4x or y square is equals to plus 4x type. So that is y minus k whole square equals to plus 4x or minus 4a x minus h likewise. So this is equals to 3 into this is y plus 5 by 6 whole square minus 25 by 6 square 36 minus 2 by 3 is equals to minus x. That is, I am just trying to convert this into a plus b whole square. A square plus 2ab plus b square. See this, y square, y I have taken, plus the quotient of y is 5 by 3, take its half, complete the square, minus 5 by 6 whole square is 25 by 36 minus 2 by 3. So if you simplify this, again we are getting this. Okay, otherwise see it. Y square 5 by 6 is 25 by 6 square 36 plus 2 into y into 5 by 6 minus 25 by 36 minus 2 by 3. So this is 3 times plus 25 by 36 minus 25 by 36 gets cancelled, minus 2 by 3. So we can write like that. So that is equals to 3 into y plus 5 by 6 whole square minus, here LCM is 36, so minus 25 minus 3 12s are 36, 3 12s are 36, 12 2s are 24, minus 25 minus 24 is minus 49 by 36, that is 7 by 6 whole square. 49 by 36 is 7 by 6 whole square is equals to minus x. So this is equals to 3 into y plus 5 by 6 whole square minus 3 into 7 square is 49 by 6 square is 36. 7 square is 49, 6 square is 36, 3 into, so 3 12s are 36 is equals to minus x. So this is 3 into y plus 5 by 6 whole square is equals to minus x plus, this is 40, otherwise 3 into this, okay, so minus x plus 49 by 12, minus x plus 49 by 12, so this is equals to 3 into y plus 5 by 6 whole square minus of x minus of 49 by 12. So this is equals to y plus 5 by 6 whole square is equals to minus of 1 by 3 into x minus of 49 by 12. Therefore, this is the parabola. This can be written as y minus of minus 5 by 6 whole square is equals to minus 1 by 3 into x minus 49 by 12. So this is a parabola having vertex at, vertex is not needed for us, but actually how it behaves. Okay na? Open in positive x-axis, negative x-axis, positive y-axis, negative y-axis. So symmetric about which axis, for which actually we have done all this process. This is a parabola having vertex at 49 by 12 comma minus 5 by 6. So, and symmetric about, see this here, y power when symmetric about x-axis, negative x-axis. Here x has got negative sign, negative x-axis. So based on this, let us try to draw the diagram. So let us take this coordinate axis now. And one more thing, so here we did not find the point of intersection, where of course 49 by 12 minus 5 by 6 is plus minus, that is fourth quadrant. So 49 by 12 is roughly 12 4s are 48, so 4 point something this is. So this is Okay, this is 1, 2, 3, 4. So 49 by 12 is 4 point something. So somewhere here, and minus 5 by 6 is 6, 5. 0.8. That means 0.8 is below here, somewhere here. So therefore it's having vertex here. So this is 49 by 12 comma minus 5 by 6. Its vertex is 49 by 12. So how do we get this point? 49 by 12 is roughly 12 fours are 48. So here this is 1, 2, 3, 4. Here 49 by 12. And minus 5 by 6 is 0.8 approximately. That is, if this is 1, so a little bit above here. So 49 by 12 and symmetric about the negative x-axis. So that means having vertex here, so it will be opened in the negative x-axis. That means here. So in the process of this, actually it will cut the y-axis here. Automatically if you extend here, it cuts the y-axis. So where this parabola cuts the y-axis, so that's we have to find out. How? Just by solving them. Solving, we get this is 2 minus 5y minus 3y square is equals to 0. This is 3y square plus 5y minus 2 equals to 0. This is equals to 3 2s are minus 6. 3 2s are minus 6. So this is 6 1s are 6. Plus 6y minus y minus 2 equals to 0. 3y if you take common, y plus 2 minus 1 if I take common, y plus 2 equals to 0. So this is y plus 2 into 3y minus 1 equals to 0. Therefore, y is equals to minus 2 comma 3y minus 1. So y equals to 1 by 3. Therefore, it cuts at minus 2 and 1 by 3. So this is, so 1 by 3 is somewhere here and minus 2 is here. Minus 2 is here. So this is the area of the region. So 1 by 3 is 0.33. So for example, this is 1 and this is 0.33 for example. This is 1 by 3, okay? So therefore, this is the parabola we are looking for. So therefore, this area is easy now. So actually just to know the behavior of this, actually we had to undergo this complex process. So therefore, what is the area now? Area is equals to from this is minus 2 and this is 1 by 3. So minus 2 to 1 by 3. Minus 2 to 1 by 3 are the limits of y. dy is x dy. That means minus 2 to 1 by 3. X is this dy. So minus 2 to 1 by 3 x dy. So this area we need to get, right? But this is not symmetric about x-axis because 1 by 3 is here, minus 2 is here. Had it been minus 2 to 2, it would be symmetric. So 2 into, so from this to this we will evaluate, and with 2 we would have multiplied. But actually that is not the case here. This is 1 by 3, this is minus 2, which is not symmetric. Now integral 2 dy is 2y minus 5 integral y dy is y square by 2 minus 3 into integral y square dy is y power 2 plus 1 by 2 plus 1 y cube by 3. The process of integration is over. Minus 2 to 1 by 3. This is equals to 2 into, in the place of y upper limit 1 by 3 minus, in the place of y lower limit is minus 2 minus this is 5 by 2 into in the place of y upper limit 1 by 3 whole square 1 by 9 minus 2 whole square is 4. This is minus is upper limit minus lower limit minus here. Minus 2 whole square is plus 4. So minus 4 totally. This is over. 3 gets cancelled. Minus of. This is y cube. Y cube is 1 by 3 whole cube. 1 by 27. Minus 2 whole cube is minus 8. Minus of minus plus 8. This is equals to. This is 2. This is 3 2s are minus 6. This is 1 by 3. Minus of minus plus 2. 2 3s are 6. 6 plus 1 7. So 2 7s are 14 by 3. This is totally. Minus 5 by 2. 9 4s are minus 36 plus 1 minus 35 by 9. Minus this is 27 8s 216 plus 1 by 27. This is equals to 14 by 3. 14 by 3 minus into minus plus 535s 175 by 2 9s are 18 minus 217 by 27. So this is equals to LCM is 54, 3, 18, 27. 54 by 3 is 18, 18, 14, so 252 plus 54 by 18, 3. So 3 into 175 is 525 minus 54 by 27 is 2. 2 into 217 is 434. This is equals to 252 minus 525 is 777 minus 434 by 54. Therefore, the answer is 343 by 54 square unit. Find the area in square units bounded by the x-axis part of the curve y is equals to 1 plus 8 by x square and the coordinates x equals to 2 and x equals to 4. X equals to 2 is the line which is parallel to y-axis, is a vertical line. So is the case with x equals to 4 also. But this is an unknown curve which we don't know its behavior of this curve. So that's why 2, 4. So 1 unit or x-axis will take 2, 3, 4. Based on 2, 3, 4, let us try to substitute this value in y. Then we will be getting y also. So based on this table, we will try to plot the diagram to know its behavior of the curve. So for which x is equals to 2, 3, 4. This is x. So y is equals to 1 plus 8 by x square curve is this. 1 plus 8 by x square curve. Now 1 plus 8 by 2 square 4. So 4 2s are 8. 1 plus 2 is 3. Next 1 plus 8 by x square is 9. So 9 8 0 point. So 8 9s are 72. So 0.8 approximately. So 0.8 plus 1. This is 1.8. Likewise 1 plus 8 by x square is 4 square 16. So this is 2 times. 1 plus 1 by 2 is 3 by 2. 3 by 2 is 1.5. Therefore, let us try to plot the diagram of this. This is positive x-axis, negative x-axis, origin. Now this is 1, 2, 3, 4. So 2, 3, 4, 1. And now this is 1. This is 1. This is 1.5. This is 1.8. And somewhere here 3. Now 2, 3. 2, 3 is here. Next, 3, 1.8. 3, 1.8 is here. Next, 4, 1.5. 4, 1.5 is somewhere here. So this is the part of the curve. So we don't know how it behaves. Okay. And now x is equals to 2 is this line. X is equals to 2 is this line. This is x equals to 2 and x equals to 4 is this line. This is x equals to 4, x equals to 2, x equals to 4 and this is the given curve. So therefore this area of the region bounded by the curve we need to evaluate. So therefore area A is equals to from 2 to 4. 2 to 4 are the limits of x. Dx means y dx. So 2 to 4 y is 1 plus 8 by x square dx. This is integral 1 dx. 2 to 4 plus 8 into integral 1 by x square dx from 2 to 4. So integral 1 dx is x. The process of integration is over. 2 to 4 I am writing here. 8 integral 1 by x square is minus 1 by x from 2 to 4. This is in the place of x upper limit 4 minus in the place of x lower limit 2. Plus into minus minus 8. 1 by x is 1 by 4 minus 1 by x is 2. This is equals to 4 minus 2 is 2 minus 8. 4 to LCM is 4. This is 1 time minus 4 by 2 is 2. 2 into 1 2. This is equals to 2 minus 8 into this is minus 1 by 4. 4 2s are 8. So this is 2. Minus into minus plus 2 1s are 2. Answer is 4 square units. Find the area of the region bounded by the curve y is equals to ln x. Means is a log x function. The x-axis and the straight line x equals to e. Y is equals to log x is not a bounded curve. So it is an open curve. And x-axis means y equals to 0. And the straight line x equals to e is e means it is a straight line which is parallel to y-axis. To be more specific, it is a vertical line. So therefore, since it is not bounded, so x equals to e and this should cut each other. Then the area of the region so formed is what we need to find out. That's why. So the point of intersection. The point of intersection of the curve y is equals to log x and x-axis. X-axis means that is y equals to 0. So substitute y is equals to 0 is equals to log x. If 0 is equals to log x, that means x equals to 1. Therefore, the point of intersection is point of intersection is 1, 0. That is lying on the x-axis. And x equals to e. Already we have discussed x equals to e. E is lying in between 2 and 3. Approximately it is 2.7. So let us take x is equals to 0, x equals to 1 and e. So y is equals to log x. Function is this. So y is equals to log x. Y is equals to log x. Log 1 value is 0. Next, y is equals to log e. X is e. Log e. Log e to the base e is equals to how much? 1, because x power 1 equals to x. 1 is equals to log x to the base x. So same to the base same is there. It is 1. So needless to say, These logarithms have the base e, Napier logarithm 1. So here it is 0 because log 1, this value is 0. Log e to the base e is 1. Therefore, we get 1 comma 0 here and e comma 1. So let us try to draw the diagram now. So this is 1, this is 2, 3, 2.7 is somewhere here. This is the point E. Now this is 1. Okay. So 1 comma 0 will lie here and E comma 1. E comma 1 will be here. That means, so this is the log x curve. This is the log x curve. Now, this is x equals to e is this line. Now, this area of the region we need to find out. Therefore, this is y is equals to log x is this curve. This curve. X equals to e is the vertical line. X-axis is this. So actually here some area has been generated. So area A is equals to integral 1 to e. 1 to e. This is y dx. So 1 to e. Y here is ln x, that is log x, that is upper function, minus the lower curve is x-axis. X-axis is y equals to 0 dx. This means 1 to e log x dx. Log x derivative we know, x log x minus x. X log x minus x. How? Log x into 1. If you take log x first function into 1 is the second function by parts, then we will get this 1 to e. So this is equals to e log e. E log e. Since the process of integration is over, substitute the upper limit in x. E log e minus e minus lower limit 1 log 1 minus 1. E log e means e to the base e. Log e to the base e is 1. E into 1 e minus e minus log 1 value is 0 minus 1. So e minus e 0, minus of minus is plus 1. Therefore this is the area of the region bounded by log x, x-axis and x equals to e. Find the area of the region xy such that x square minus x minus 1 less than or equals to y less than or equals to minus 1. So this is an inequality. So far we have done the equality problems. This is inequality. So how do we do this? Solution is equals to 0 will take first. So given curves are. So this is x square minus x minus 1 is equals to y and y is equals to minus 1. So we know that y is equals to minus 1. Y is equals to k is the line which is parallel to x-axis, that is a horizontal line. So x square minus x minus 1 is equals to y is a parabola whose vertex we don't know, which we need to find out first. And where it cuts the x-axis also or y-axis we need to find out. Simply, if you want to know where the parabola cuts the x-axis, simply substitute y equals to 0. And if you want to know where the parabola cuts the y-axis, simply substitute x equals to 0. In this way we need to do. Now first x square minus x minus 1 equals to y. This is equals to x square minus x is equals to y plus 1. This implies x minus 1 by 2 whole square minus 1 by 4. So this I am trying it to convert in a minus b whole square. You can see here x square a square plus b square 1 by 2 whole square, which is 1 by 4. 1 by 4, 1 by 4 gets cancelled. Minus 2ab, minus 2 into x into 1 by 2. 2 gets cancelled, I left with x. Is equals to y plus 1. This is equals to x minus half whole square is equals to y plus 1 by 4 is 5 by 4. Therefore, it is x minus half whole square is equals to y minus half minus 5 by 4. Therefore, this is a parabola having vertex at 1 by 2 comma minus 5 by 4 and symmetric about, see, x power even, symmetric about y axis. Which y axis? Positive y axis. Positive y axis. So this is equals to, so let us try to draw the diagram first. So this is somewhat like here. So this is 1 by 2, this is 1, this is 1, this is 2. So 1 by 2 is 0.5, this is 1 by 2, 1, this is 1 by 2, 1, minus 1 by 2, minus 1. So 1 by 2 minus 5 by 4 is lying in the fourth quadrant. Plus plus minus plus minus minus plus minus. So 1 by 2 is 0.5, minus 5.4 is minus 1.1 is somewhere like here. So this is the little downwards, because 4 by 5 when you divide, 4 ones are 4, 1.0, 4 twos are 8 and 4 fives are 20. So minus 1.25 is somewhere down here. Okay. So this is the vertex of this. So the parabola having vertex at 1 by 2 comma minus 5 by 4. The parabola having vertex at 1 by 2 comma minus 5 by 4 and open in x power even, symmetric about y axis. So for example, this is the y axis, upward parabola. So in the same fashion, so it will be like this. And if you want to know where it cuts the x-axis, simply substitute x is equals to 0 in this. Or simply where it cuts the x-axis, simply substitute x-axis means y is equals to 0. Substitute then. So x square minus x minus 1 is equals to 0. So x is equals to minus 1 plus or minus square root of b square minus 4ac. 4 ones are 4 by 2a. So 1 plus or minus root 5 by 2. So 1 plus root 5 by 2 will be somewhere here, and 1 minus root 5 by 2. 1 minus root 5 by 2 is here. Root 5 value is 2 point something. 2 plus 1 3. 3 by 2 is 1.5 somewhere here. Okay. So it will. So this we no need to find, but just to understand the curve's behavior, x equals to 0, we have y equals to 0, we substituted and we got this. Okay, now, and y is equals to minus 1. Y is equals to minus 1 is the line which is horizontal to x-axis. So this is y is equals to minus 1, and this is x square minus x minus 1 is equals to y. Okay. Now since it is an inequality, now we shall take the inequalities. X square minus x minus 1 less than or equals to y, and this is y less than or equals to minus 1. So let us substitute 0, 0. This is origin side. So this is how we will do the inequality. So actually we can take any point, but for the sake of convenience 0, 0. That means this is the parabola. So less than y means actually this is the area of the region will be upward or downward, we should know. For which 0, 0 I will substitute. Then let us see what will happen. 0 minus 1 less than or equals to y is 0. So minus 1 less than 0. Minus 1 less than or equals to 0 means minus 1 less than 0. One of the two conditions must follow. So minus 1 less than 0 means yes, since this inequality holds good, it satisfies this inequality. Therefore, the area of the region bounded by the curve y is equals to x square minus x minus y is towards the origin side. Origin side is this. If it is not satisfied, then actually it will come downwards. Therefore, this is the area now. And so here y less than or equals to 1. Again take 0, 0. So 0 less than or equals to minus 1. How come is it possible? No. Therefore, the origin will not follow. The origin, this line. So this is y is equals to 1. Okay. Y less than or equals to minus 1 is an inequality. That is the half plane towards upside or downwards. That we know. But here 0 less than or equals to minus 1. So therefore, it will be here downwards. It won't it did not fulfill the above side. Therefore, it will be this side. So both x square minus x minus 1 parabola and this intersecting at this area. This area. So now we have to know area is equals to. Now both are intersecting at 1 because so the intersection point of these two, x square minus x minus 1 and y equals to minus y. So according to the diagram, both are intersecting at 1 it seems, but actually that is the diagram. We can draw this in any way, but mathematically how do we get the point of intersection? Solving x square minus x minus 1 equals to y and y equals to minus 1. We shall get x square minus x minus 1, y value is minus 1. Minus 1 gets cancelled. X into x minus 1 equals to 0. Therefore, x is equals to 0 or x is equals to 1. Therefore, this is the area you can see here. So, this is 1. Okay, and this is 0. This area we want. Therefore, area is equals to 0 to 1. The upper curve is, this is 0 to 1 or the limits of x. So, dx, y dx. This is equals to 0 to 1. Here, y is equals to minus 1, y is equals to this. Two curves are there. First is the line. First is the y line minus y. Down of this is a parabola, yp dx. This is equals to 0 to 1. Y line is minus 1. Minus of, this is, parabola is x square minus x minus 1 whole dx. This is equals to 0 to 1. This is minus 1. Minus into minus plus 1. Both gets cancelled. So this is minus x square. This is plus x. This is x minus x square dx. Integral x dx is x square by 2 minus integral x square dx is x cube by 3 from 0 to 1. This is equals to 1 by 2 minus 1 by 3. That is equals to 1 by 6 square units. Find the area of the region enclosed by the curves. Y is equals to sin pi x. Y is equals to x square minus x. X equals to 2. So, x square minus x is the parabola. Y is equals to sin pi x. Sine curve we know. this it will go, and x equals to 2 is the line which is parallel to y axis, that is a vertical line. Now, so all that we need to do is both are never intersect, but one point of intersection on x axis we will get. The other point, since it both are open curves, so at x equals to 2 we should restrict, and then we need to find out the area under curve under the first point of intersection to x equals to 2, for which solution y is equals to sin pi x. So first of all, the given curve is y is equals to x square minus x. It is a parabola. How? So this can be written as x minus 1 by 2 whole square minus 1 by 4 y equals to, therefore it is y plus 1 by 4. So that is y plus 1 by 4. So y minus of 1 by 4 we can write is equals to x minus 1 by 2 whole square. Therefore it is a parabola whose vertex is at 1 by 2 comma minus 1 by 4 and symmetric about x power even symmetric about y axis. Which y axis? Positive y axis. Positive y axis. That means it's a upward parabola. And y is equals to sin pi x we know, for which let us okay, so let us draw the diagram taking 1 by 2. So this is minus 1 by 2, this is minus 1, 0, 1 by 2, 1, 3 by 2, this is 2. Now quickly substitute. Y is equals to sin pi x. Sin pi into minus 1. Sin minus pi minus sin pi minus sin 180 is sin 90 plus 90 minus cos 90, so minus 1. So this is plus 1, this is minus 1. Sin pi into minus 1 is minus sin minus pi. Sin minus pi is minus sin pi. Minus sin pi is 180. Sin 90 plus 90. So minus sin 90 plus 90 is minus cos 90. Sin 90 plus 90 is cos 90. Cos 90 value is 0. So it will be 0. Sin pi into minus 1 by 2. So minus pi by 2 minus sin pi by 2. So this is minus 1. So at minus 1 by 2 it is minus 1 here. Next, sin pi into 0. Sin pi into 0 is 0. Sin 0 is 0. Next, sin pi into 1 by 2. Sin pi by 2. Sin 90 value is 1. So it will be here. Next, sin pi into 1. Sin pi. Sin 180. Sin 90 plus 90. Cos 90. Cos 90 value is 0. Here. Next, sin pi into x is 3 pi by 2. Sin 3 pi by 2. Sin 180 plus 90 minus sin 90. So minus 1. So this is here. Next, sin 2 pi. Sin 360. 2 into pi is 180. 360. That is 0. So therefore if you join the curve, so this is how it will look like. This is y is equals to sin pi x curve. And x square minus x, substitute here. So both are intersecting at x square value is, for example, 0 I will take. So 0 square minus 0. So it will be 0 here. Next, 1 by 2 if you substitute, 1 by 4, this is 1 by 4 minus 1 by 2. So 4, 1 minus 2 minus 1 by 4. So minus 0.25. Minus 0.25 is somewhere here. Next, 1 you substitute, 1 square minus 1, it is 0. Okay, and so this is next. 3 by 2 you substitute, 3 by 2 whole square, 9 by 4 minus 3 by 2 whole square is 9 by 4 minus x value is 3 by 2. So 4 LCM, 9 minus 2 3s are 6. So 3 by 4. 3 by 4 is 3 into 0.25. That means 0.75. 0.75 will be somewhere down of 1. So somewhere here. Next, after 3 by 2, 2. 2 you substitute, 2 square, 4 minus 2, that is 2. So this is 2 here. Okay, this is 2. Now both are intersecting at this region. So it is not a bounded curve, so it is an open curve, it goes like somewhere, but actually that we don't want. X is equals to 2 means this is the line. So this is x equals to 2 and this is y is equals to x square minus x, and this is sin pi x. This is y is equals to sin pi x, and this is y is equals to x square minus x. So this is the area of the region bounded by the two curves we want to find. Therefore area is equals to, from 1 to 2, because at 1 both are intersecting, but both are not intersecting anywhere, but actually we should restrict to x equals to 2 here. So 1 to 2 y dx. So 1 to 2, what is y here? That is the x square minus x upper curve minus the lower curve is sin pi x. So all we need to do is to evaluate the integration for this. Now this is equal to integral x square dx is x cube by 3, integral x dx is x square by 2 minus sin pi x. Let us suppose this pi x to be x, sin x derivative is minus cos, minus of sin x integration is minus cos, minus of minus plus cos pi x, and we should divide it by the quotient of x pi. So therefore integration process is over. Now 1 to 2 limits. So x cube by 3, this is 1 by 3 into x cube is 2 cube minus 1 cube minus 1 by 2 into 2 square minus 1 square plus 1 by pi into cos pi into 2 pi minus cos 1 into pi is pi. So this is equals to 2 cube is 8 minus 1, 7 by 3. Next 2 square 4 minus 1, 3 by 2 plus 1 by pi cos 360. Cos 360 minus 0. Cos 0. Cos 0 value is 1. Cos 0 value is 1. Cos pi. Cos 180. Cos 90 plus 90 minus sin 90. This is cos pi is cos 180. Cos 90 plus 90 minus sin 90. So minus 1. So cos pi value is minus 1. Minus of minus is plus 1. So that is equals to, if you find LCM here, 3 2s are 6. So 7 3s are 14 minus 3 3s are 9 plus 1 plus 1 2 by pi. This is equals to 14 minus 9 is 5 by 6 plus 2 by pi square units. With this, we will wind up the definite integrals chapter.